Um, just before we kind of jump into agility, I just want to kind of a quick recap, just in case you missed some of the earlier parts of the series. So first thing, just to kind of clarify on what is a container. Well, a container is your application code and the binaries and libraries required to run your application, all packaged up. A container can run on virtual machines, it can run on physical servers, honestly don't mind. Containers share the underlying host's kernel and networking stack. So inside of the container, you would have, for example, your application code and maybe IIS, the web framework, or maybe your application code and OpenJDK. Whereas the underlying kernel and the underlying networking stack would be shared between multiple containers. The Docker engine is a small lightweight layer that we install on our hosts, and the Docker engine's job is to create and start and stop those containers. Today we support Linux containers absolutely fine and Windows containers absolutely fine, but one thing to bear in mind, as we're not packaging up the kernel and we're not emulating the operating system anywhere, a good rule of thumb is that Windows containers run on Windows hosts and Linux containers run on Linux hosts. The main goal here for Docker is really to be able to support any application across any operating system, across any infrastructure. Really separating and abstracting the application from the environment in which it's running on. Today we have end users using Docker for traditional applications, for modern microservice-based applications, and now we're starting to see more and more customers taking advantage of Docker for more modern projects like blockchain or serverless. The Docker platform then sits in the middle, separating your application from the underlying infrastructure, whether your infrastructure is in a cloud environment, in virtual machines, or on bare metal. We absolutely don't mind. We make sure that there are 3 core pillars inside of the Docker platform that kind of underpin the strategy and direction of everything we do. And those 3 pillars are choice, agility, and security. And if you've been following along with this series, you would have known that we've actually started to work our way through the second webinar was looking at choice in more detail, the third, security, and this fourth one on agility. Just kind of looking at those in a little bit more detail to try and understand where some of the design goals we have for our platform. On the choice side, we really are focusing on any application, new application or legacy. We honestly don't mind. We want to provide a seamless experience no matter what you're working on. And that comes the same on infrastructure. We're really trying to avoid, try and prevent you guys being locked into a particular platform or architecture. We're really providing an abstraction between your application and the OS. On the security side, we want to make sure that we embed as much security as default into the platform, integrating security at every level, from the container to the container orchestration to the management tools. And then from the agility perspective, where we'll focus on more today, we're looking at how we can reduce the time taken to roll out software, or maybe reduce the time taken to patch new software. How we can start to integrate and automate more and more and kind of integrate into existing tool chains and pipelines. And we're also looking at agility, how we can reduce the overhead of getting started with containers and reduce the overhead that often more and more applications, more and more microservices put on infrastructure. There are some common use cases for Docker Enterprise, and we're kind of going through these as we go through the series, whether that's looking at modernizing traditional applications by containerizing legacy or brownfield applications, whether that's using Docker Enterprise as part of a cloud strategy or reducing infrastructure expense, using Docker Enterprise to kind of speed up the deployment of applications or securing your software supply chain, or finally using Docker Enterprise to help deploy and roll out software at the edge. In this particular webinar, the technology that we'll be talking through today will help you really deploy or roll out applications faster, and really secure applications through the supply chain, integrating containers with your native, with your existing or new and modern pipelines. So first off, we'll have a look at agility for developers, and then later on in the webinar, we'll switch to agility on the operator side. So just a quick look on kind of the landscape on the ecosystem today. We can see that the number of hosts out there today running containers or running the Docker engine are growing year on year. And even if you look at Datadog as a source of data for this, you can see that 20% of the hosts that they monitor are running the Docker engine, and that keeps growing. And then at the same time, on the right-hand side, you can see that on the number of hosts that they have, not only the number of hosts is growing, but the number of containers per host is constantly growing as well. So what that means is that there are more and more developers today developing applications in containers than ever before. And we in Docker need to make sure that we're working hard to enable more and more developers, make it easier for them to get started with containers, and make it more and more seamless to integrate with their existing processes and tooling. But today, if you are a developer inside of an enterprise or inside of a large corporation, there are kind of a few key pillars that Docker can help with. The first kind of friction or question we get from developers is they want to understand when getting started, how can they have access to a local development environment? How can they work on containers within their corporate firewalls, or on their corporate machines or corporate laptops? What is the quickest and easiest way for them to get access to environment to work on containers? The next question that often comes up is, well, how can we closely integrate with their existing tooling and processes? Developers today are often quite tied to their development environments, their IDEs. They're familiar with common DevOps toolings, maybe, for example, Git for source control, and maybe things like Jenkins or DevOps on the pipeline side. How can, when the switch happens to start to containerize applications in containers, how can we reduce the learning curve and seamlessly integrate with those tools? And then finally, one of the other big points and questions that often get asked when developers start to look at Docker is how can they get started? How can they reduce what we'll kind of call the Docker learning curve? Just on my screen there are two snippets of a Docker file, which defines a container image, and a Kubernetes manifest file, which defines what an application looks like. Those two objects are often very complex, and there's an awful lot of specific reference guides that you have to follow and to understand how to develop a containerized application. One of the kind of key focuses for us in Docker is trying to work out how to simplify the processes so that if a Java developer or a .NET developer gets started with containers, they don't have to spend the first week or two just sat there and studying all the various syntaxes and kind of flags. We want to really reduce the overhead on getting started with containers. Really providing agility for developers, getting them into containers sooner and quicker. And one of the biggest tools that we have to try and solve some of these challenges is a product that we recently announced in December in Barcelona, and that product was Docker Desktop Enterprise. Docker Desktop Enterprise is a local environment for working with containers. It runs locally on your machines, whether that's a Windows machine or a Mac. For developers, it provides a local environment which is really giving them choice. It's not locked into specific frameworks. We're not saying that they have to use, I don't know, maybe Spring or maybe have to use Java. We really provide a whole range of all the things that can be containerized can work locally on their development environment. We're working hard to seamlessly integrate Docker Desktop Enterprise with their existing workflow, their existing IDEs and pipelines. And we're trying to abstract containers away as much as we can to reduce the container expertise required. For operators, Docker Desktop Enterprise provides a local development environment that they can control. Operators can roll out Docker Desktop Enterprise using their MDM solutions, using things like, I don't know, System Center or something to roll out Docker Desktop to all of their corporate machines. And we're providing ways for operators to lock down settings inside of their local development environment, maybe lock down the proxy settings, the networking settings, for example, for the developers. And we're also providing a way for operators to control updates and control versioning. So a bit more looking at, well, what is Docker Desktop Enterprise and how can I use it for a local development environment? Well, firstly, it avoids, if you're a developer, the works on my machine problem. A developer can create a containerized application locally or work on a containerized application locally and know that when they want to publish that container image, all they have to do is push up the Docker file or push up the container image to the registry, and everything required to run that application will be embedded inside of that container image. For developers, we're providing choice. Any language and any framework we're working hard to support in containers on top of Docker. We can actually support both Windows and Linux containers as part of Docker Desktop. You may say, well, earlier on, Ollie, you said that Windows containers require a Windows host and Linux containers require a Linux host. So how can I develop Linux containers on my corporate Windows machine? Well, we actually run a really lightweight virtual machine as part of Docker Desktop. Something we manage, we seamlessly handle the upgrade, the hardening, the patching of as part of Docker Desktop. And that's a really lightweight Linux virtual machine. And then we work really, really hard to seamlessly integrate the networking and the file system of the corporate desktop into that virtual machine. So for example, if you hit localhost on the corporate desktop, you're actually hitting the networking stack of the virtual machine. So we're really kind of providing a development environment for Linux applications on a Windows desktop. If you're working with Windows containers and Windows applications, then it'll seamlessly integrate using the native Windows operating system that your environment's running on. For Mac OS, we provide that native Linux environment again through the virtual machine. However, today we don't package up a Windows environment to develop Windows containers on a Mac virtual machine, on a Mac desktop. Docker Desktop Enterprise provides an environment to work with containers with a local Docker engine, as well as work with container orchestration with local environments for Docker Swarm, as well as a certified and managed Kubernetes distribution. If developers are being asked to work on Kubernetes applications or containerized applications that are going to be deployed in a Kubernetes environment, we now provide the easiest way to get up and running with Kubernetes locally. One simple tick box inside of the UI will start up a Kubernetes distribution on your corporate machine. So let's have a look at a quick demo. So here I am on my corporate machine, and I'm running Windows 10 here. As part of Windows 10, my administrators have pushed out to me a Docker Desktop Enterprise. You can see that it's running as a background task, just looking at the taskbar in the corner. A quick check. This is, of course, running Docker Desktop Enterprise. One of the most requested things for a local development environment is where developers want to version match the version of Docker that they're running and developing on with the version of Docker or the version of Kubernetes that they're running in production inside of the data center. Going back to that, it works on my machine. Not only do they want to test their application in a container, but they want to test their application in a container on the same version of Docker and the same version of Kubernetes. One of the key things that we provide as part of Desktop is the ability to select the version, and we release these things called version packs, where you can specify different versions of the engine and different versions of Kubernetes. Here you'll see that we're switching between Docker Enterprise 2.1 and 2.0, which are in actual fact is Kubernetes 1.11 and 1.8. Just with a tick of a button, I'm able to test against both environments. And you can see here that the administrator is actually locked down. You can see locked by the administrator, where my admin has said, well, those are the two versions you get to work with. We haven't quite finished rolling out anything else yet, so that's kind of a corporate environment for you to work in. Inside of the settings menu, you'll see ways to configure desktop and configure the local development environment, including the option here to enable Kubernetes. One simple tick box, I have a local development environment. But this particular session is all about developer agility. So how, as a developer, can I get started with containers really, really quickly? I don't want to spend a few weeks learning syntaxes. I don't want to spend a few weeks learning CLI reference guides. What is the quickest way for me to start working on a containerized application? And inside of Docker Desktop Enterprise, we provide an application designer, UI-driven or wizard-driven UI to create containerized applications. So I'm a developer. I've just been given the task to work on a new free-tiered application. And I want to choose a free-tiered application, which is pretty standard inside of my enterprise. It's a Linux application, and my application is going to include a Flask component. It's going to include a MySQL backend, and it's going to include a HTTP proxy at the front powered by Nginx. Of course, these templates are absolutely customizable. You may build templates that are suited to your environment. These are just a few that we include out of the box. So developer turns up, doesn't know anything about a Docker file, doesn't know too much about what the process is to containerize an application, but he just knows I need those free components. I want to spend as little time as possible getting a local development environment up and running. So click that in the wizard. If I had any preference around Python versions or MySQL versions, I can customize that, but let's leave those as default. Hit continue, name my application, webinar demo, and assemble. You just see me there go a few clicks through a wizard, and I've got a containerized free tier application running locally on my corporate Windows 10 machine. If I run the application, hopefully we'll see all of the logging filter through as it starts up the various components. It'll start up the proxy, start up the Flask layer in the middle, and then start up the database. It kind of floats through. A quick test from myself to make sure that everything's working successfully. If I open up a web browser, hit localhost, perfect, I can actually see the Flask element in my application producing hello world. At that point, the developer's good to go. He's got his components. He's going to start working on his application. I'm going to quickly open up this in an IDE, so seamlessly integrate into VS Code here, and I'm now inside the source code for my application. Then look here on the left-hand side, you can see that there is the back-end application, a database, and a proxy. Once again, I haven't had to understand what a Docker file is. I haven't had to understand how to define how those free services interact. That's all been given to me by a simple wizard. Developer may now come in here and say, okay, well, instead of saying hello world, let's change it to hello webinar. To rebuild my application, jump back into my user interface and restart. At that point, we'll rebuild all the container images for you from the source code. Well, first off, we have to shut down. Then once everything's shut down, we'll rebuild everything back up again using new versions of my source code. And once all that's gone through, we should be able to hit localhost again, and Flask should now say, hello webinar. Perfect. So I've seamlessly now gone from having very little Docker knowledge or expertise to be able to work with a containerized application in my IDE just through a few clicks. The next question that may be, well, how do I share what I've been working on? Well, maybe you want to now push your container images that you've been working on locally up to your shared enterprise registry. The way that you would do that, jump back into your IDE. For this, I'm just going to have to do a little bit of a manual task. I'm just going to have to rename my container images to something that points to my container registry. Once I've pointed my images to the container registry rather than to my local machine, I can rename them using Docker Compose. And I can push them up to the registry. What I've just done there is I've taken the container images that were pushed out of my template. I've renamed them so that they can be pushed to a container registry, and I've just pushed them. So now, if I switch to Docker Trusted Registry, which is where which we have as a component of Docker Enterprise, you will see 26 seconds ago, a new container version was pushed up to the registry, and it's automatically by default been scanned for vulnerabilities. And there's more content on what was actually scanned as part of a vulnerability scan inside of the security webinar in the previous webinar number 3. So what have I just kind of done, and kind of go through, remember the kind of reducing the friction and providing more agility for our developers. Well, I've given my developers a local development environment. I've given them something that I can control the rollout of via operator tools like MDM solutions for both Windows and for Mac. I've given them a local development environment for Docker, as well as a local development environment for Kubernetes. I've shown integration with existing tools. So you saw me there editing the application code in Visual Studio. As well there, you actually saw everything in clear text. So if I wanted to, I could easily check that application then and there into source control. So my application can straight be versioned, and we can have collaboration with the rest of the team. And you saw how I was able to reduce the Docker learning curve by providing a wizard to abstract all of the complexities of a Docker file and of application definition from the developer. Okay, so next kind of question, how can we start to provide agility for the operators? So one of the most common questions I get asked as part of solution engineering in Docker is well, how do I integrate this into my pipeline? Or do containers complement, or how does containers and pipelines kind of work together? They're very big technology in the ecosystem right now. A lot of people are looking at both their container strategies, their DevOps strategies, and their pipeline strategies. And one thing I will say is they absolutely all go hand in hand. We often find that container strategies drive people's pipeline decisions. And one of the core things and one of the core principles we provide inside of Docker Enterprise is choice. And one of the things that we try really, really hard to do is work with as many of the existing and leading pipeline tools as we can. On the screen here, I've included a few tools, but I really want to stress that there are a lot more tools out there today that we can work with. These are just some of the logos that I've pulled together. And one of the key things here is as developers start to build containerized applications, automation through pipelines is often the way to take the application from source code, building it in a container, testing it, securing it, and rolling it out. We often find that as part of developing applications in containers, the pipeline provides the automation to take it from the local development environment that you just saw into production. Therefore, the whole kind of relating this back, what we're trying to do here is reduce the time taken to roll out new software, test new software, and roll out patch releases. So if we look at the containerized software supply chain, if you really kind of looked at it from like 10,000 feet and simplified it a little bit, pipelines really revolve around four key steps: building, testing, securing, and I will stress that securing often happens across, but for simplicity's sake, I've kind of called it its own section, but we often do see security underpin everything. And then deployment. So the question then becomes, how can containerization and how can Docker Enterprise complement each stage of the supply chain? Well, Let's start on the build side. As part of rolling out containers and as part of Docker using Docker Enterprise, what you're able to do is you're able to have standardization in your building artifacts. The application, once it's built into a container image, will be able to go through the life cycle of its journey because everything in a container image, everything required to run that application is packaged up inside of the container image. At the same time, we'll end up on standardization for all of your application types. If you're building your legacy applications and you're building your modern microservices, you could be able to use the same tools and the same processes because Docker abstracts the application from the infrastructure. As well as that, on the build layer, we're actually able to start to reduce complexity and reduce the infrastructure required to support a pipeline through containerizing build agents. And we'll look a bit more about that in the demo in a moment. Next, moving into testing. As part of the testing phase, containerization can simplify testing by providing a consistent environment from dev all the way to production. You build a container image once and pass it along. You don't have to worry about compiling it for each environment and then having to deal with all of the obscurities between the testing cluster and the pre-production cluster and the production cluster. The container image will be the same from end to end. Container images provide versioning out of the box. Image tags in a container provide a way, so once a container image is called version 1, it kind of has its version number built into its name. And containers by default enable seamless scale out, enabling parallel testing. On the security side, containers can provide a clear audit trail, and so inside of the registries we can have clear audit trail around who's pushed and pulled images. And as shown in the security webinar, we've seen how container images can be signed to verify who's built them and verify the publisher, and container images can be scanned. And then on the deploy side, we can have a look at how a pipeline can trigger the rollout of an application, and we can have a look at how container orchestrators seamlessly have rollout mechanisms to handle new software updates and new patch releases. So I kind of want to switch there into the demonstration and kind of show how each of these steps can be simplified with containers and can be simplified with Docker Enterprise. So for this, I'm going to use a very simple Noddy demonstration application. This particular application is called My Demo App. It's a very, very simple HTML-based application that just serves up a static web page. So let's kind of go back. How can I reduce the time taken to kind of roll out new releases of my application? And how can I automate the process as much as possible? I don't want to have manual steps in kind of the supply chain anymore. I want to automate this end to end. To provide automation for my application, I'm actually going to use Jenkins. And Jenkins will provide for us the automation engine to move my application from building to testing to deploying. And then at the end of the day, I have a Docker Enterprise environment running Kubernetes and Docker Swarm. And this will be the runtime for my application once it's been built, tested, and secured. So let's start out. I'm a developer, I'm using Docker Enterprise, and I'm building my application locally. The first thing I'm going to do is, as a developer, and let me just make some changes to my application. Let's make a few changes. I don't know. Oh, there's a quick typo there. Let's tidy that up. Hello, welcome to Ollie's webinar demo. Cool. So I'm a developer. I've worked on my application. I'm quite happy with it. How can I get this into the pipeline, into supply chain as quick as possible without picking up the phone and phoning all kind of the operators and kind of manually starting to work on this application? Well, first thing I'm going to do is I'm going to check my application source control. This is a demonstration, so I'm going to carelessly push it up to master, but we all know that we shouldn't be doing that. Quick look inside of my application source control. Yep, 14 seconds ago, there is a new version of my application. Great. So one of the key things now is we've looked at our pipeline, and we can see that automatically a build job has been started. The build job here is going to take my source code and it's going to create a container image for me. I have some customers that use pipelines to create container images. I have other customers that use pipelines and containers to create traditional artifacts. So maybe to create their Java jars, or maybe to kind of compile their applications. So we can absolutely use containers to build container images, or we can use containers to build standalone artifacts. One of the things that I want to talk about here is that I actually don't have a whole fleet of infrastructure sat behind my pipelines. I haven't got 5, 10 virtual machines sat there as build slaves. One of the things that containers enable me to do from an infrastructure and agility benefit, they enable me to have on-demand build agents. You would have seen that a build agent got spun up to do the job. And then once the job's finished, the agent's going to disappear. A quick look in the control plane, and I'm going to quickly switch under Jenkins. Oops, got a bit wrong. And have a look under pods. You can see that, well, less than a minute ago, a brand new container was deployed via Jenkins, and that container's job was to build my application. I haven't had to have underutilized build agents sat around waiting, and I haven't had to have build agents sat around with every single framework deployed on it because there's no standardization across the development community. What I'm able to do here is have build agents that are deployed on demand, and have build agents with only the tools required for the job. Each developer can manage their own environment. Okay, as part of my demonstration here, I've actually got my application pushed into the registry. It's gone through my pipeline. You can see 2 minutes ago, everything was pushed up to Docker Trusted Registry. It was scanned for vulnerabilities. We detected some critical vulnerabilities in BusyBox and a few other things. At that point, from an agility perspective, my pipeline is finished. We, as Docker and as part of my design of my pipeline, have said, if the application contains vulnerabilities, don't move it forward to testing, don't move it forward to deployment, send a webhook, send back feedback to the developer to say, you have components in your application that you need to patch. So that's gone back to my developer. I'm gonna go now back to my application, and I'm gonna start to customize it. What I'm gonna do is I'm gonna quickly patch my application. That's your fact, quickly patch is to change the container image and maybe change its content real quick. And a quick push up to master. What I've now done is I've restarted my supply chain. My previous supply chain failed because I had an insecure container. Now we've hopefully fixed that, and we'll start to see that the build job's going to go through for me. And if I jump in here, I'll start to see that it's going to build a container image for me and push it up to the registry. Fortunately, I'm working with quite a light environment, so it takes a few seconds to move around. A quick look inside of the registry, we can see that automatically, that didn't go very well. The container image was pushed up. That didn't go great. I'm gonna go again. Huh. 1 second to see what happened. Looked like I didn't quite take the new base image for me. Still showed some vulnerabilities. Let's try again. But what we should expect to see is a automated promotion take place. We've actually written some automation inside of our registry that says, if our container images are clean, move them up the chain. Move them from an in particular developer's repository, and I've just happened to call my developer Dave the developer, but move the container image from there into testing. That's kind of an automated step now between building and testing. We haven't had to have any manual processes. Hopefully the second go works quite well. Refresh. Oh, perfect. New image has landed and it's just being scanned for vulnerabilities. Give it a minute or two to be inventoried, and it should move on. Perfect. So it's finished. It didn't contain any critical vulnerabilities. That's because it was a newer container, and it should have nicely moved across to a testing repository, seamlessly moving the image through its lifecycle. Now, testing repositories will have different sets of permissions. They'll have different automation attached to them. In my particular demonstration, I've said, if a new image starts in testing, land it in the testing job. Now, we all know there's various different types of testing: smoke testing, integration testing, UAT, etc. All of that can be embedded inside of a pipeline. For simplicity and really to kind of reduce the time taken to run through a demonstration, I'm going to show how just a simple smoke test. I'm going to deploy my application as a container. Once it's okay, I'm going to leave it in an approval stage. If it's good, I'm going to move the container image to production. Now, one of the key things that I talked about on this slide is that there is a consistent artifact from end to end. I don't want to have to rebuild my container image every time it moves through the pipeline. And that's kind of what we have to do today, right? We have to change our application depending on which environment it's working in. If it's working in testing, I have to build it for it. If it's working for pre-prod, I have to work it for it. As part of a container image, you can build once and move between the different environments. Right, it's just about looking like testing is coming to an end, and we can move to the deployment phase. This is where I've just put a very, very manual gate in to accept that the container image is good. Hopefully, in your environments, you've got more processes around this. But I'm just going to say, is it okay to deploy to production? Yes or no? Absolutely, it is. And it's going to go away and finish the final two steps for me. What I expect to find is a production container repository that now contains all of my clean images, all of the ones that have been scanned for vulnerabilities and are okay. And I also expect to find all of my container images have been properly version numbered and signed. Now, this now becomes a very clean artifact that I'm happy that's gone end to end through my software supply chain. There was one manual step, which was a gate, a yes or no, but everything else has been automated end to end. Built once in a container and using Docker Enterprise, in this case, Docker Registry to provide my artifact store and to use Docker Enterprise as the underlying container platform. I've seamlessly moved my application from a developer's laptop right the way to production. There we go. 18 seconds ago, a clean container image. Now, when it comes to rolling out container applications, the good news for operators is that container orchestrators, so Docker Swarm and Kubernetes, come with some really great features to help you roll out application changes. They can seamlessly handle rolling out groups or updating containers one by one so that the application itself has no downtime. There's a few different ways that you can can roll out applications, whether you want to do them one by one, whether you want to do blue-green, whether you want to do canary builds. All of those things are now possible in containers. You're able to bring up the old and the new container side by side, and then decide when you want to fill traffic over to the other side. And all of those features are built in by container orchestrators and abstracted the application away from its infrastructure. Orchestrators like Swarm and Kubernetes can even handle the automatic rollback of your application if something goes wrong. So kind of going through the kind of pictorially what my demonstration just showed, it showed new code landing in source control. It saw Jenkins building my container and uploading it to a registry. The testing phase happened where, if it had no vulnerabilities, do some simple smoke tests. If the smoke tests pass, get security to sign them off and to push the image into a production repository with no vulnerabilities and an audit trail of signature data. And then when the new production image lands, get the deployment processes to start. And in my case, Jenkins would have detected that a new production image has landed, and it would have automatically a no downtime rollout to my Docker Enterprise cluster, showing both the CI and the CD side, showing how Docker Enterprise, Docker Universal Control Plane, and the trusted registry can automate or be the backbone when rolling out new versions of software or rolling out software for the first time. Hopefully through today's webinar, you've seen the various components of Docker Enterprise in action, from providing agility to the developers with Docker Desktop Enterprise, providing a local environment to work on Swarm and Kubernetes applications. We've shown how we've used the Docker Trusted Registry to publish the content that the developer creates. And then we've looked at how the Trusted Registry and the control plane can be used again to take away some of the pains from rolling out new versions of applications through a pipeline. All the way using consistent application formats, using the same container images throughout, making sure that security has been at the heart of the process when rolling out applications into production on Universal Control Plane. If you've not seen, Forrester recently published a new wave on container platforms, and there's a link to that report here, with Docker being seen as a leader in enterprise container platforms. That's it. Thank you.
Thank you, everyone. Thank you to Oliver Pomeroy, Technical Solutions Engineer at Docker. Thank you for the presentation today. This does conclude our webinar. We do appreciate all the great questions that were submitted, and we'll make sure to follow up with each one of them. I also want to remind you all that today's session was recorded, and you will receive an email to view the recording in the next few days. If you haven't already, please be sure to register for our other Docker webinars at events.docker.com. We thank you again for joining us and hope that you have a terrific day.